Evaluate integral e power ax into sine bx plus c dx. So this question is in the form of the f of x and g of x function. So we shall use integration by parts method in this question. Okay, so we'll take this function as f of x and this function of as g of x. Okay, so here f of x is equals to e power a x, right? F dash of x will be e power ax, derivative is e power ax. This is not x, so we'll write the derivative of it again, right? So x derivative will be 1, so we'll be remaining with the constant a, right? So f dash of x value will be a into e power ax, right? Next is the function g of x, which is equals to sine bx plus c. So we should find integral g of x dx, which is equals to sine bx plus c integral dx, right? So sine x integral is minus cos x. X value is this. So if this is not x, we'll write its x value. This is the constant c, so this will be derivative, this will be 0. X derivative will be 1, so we'll be left with b. So that differentiation term we should write in the denominator division form, okay, in while doing integration. Okay, so we know the formula of by parts integral f of x g of x dx is equals to f of x integral g of x dx minus integral f dash of x into integral g of x dx whole dx. Okay, so we'll consider I is equal to our this. So f of x value is e power ax into integral g of x dx is minus cos bx plus c by b minus integral f dash of x is a into e power ax into integral g of x is minus cos bx plus c by b whole dx. So this can be written as I is equal to, here it is minus 1 by b, the denominator e power ax cos bx plus c. Here minus minus will become plus and a by b is constant, integral e power ax cos bx plus c dx. So this we will consider this as I1. Okay, so we can write I is equal to minus e power ax cos bx plus c by b plus a by b into I1. Consider this as equation 1. Okay, now consider the I1 value. I1 is equal to integral e power ax into cos bx plus c dx. Again, this function is taken as f of x and this function is taken as g of x. So f of x is equals to e power ax. We should find f dash of x, which is equals to derivative of e power x is e power x. This is not x against the derivative, so it is a. Okay, so it is a into e power ax is the f dash x value. Integral g of x we have to find. Okay, so g of x is cos bx plus c. Integral of g of x dx is equals to integral of cos bx plus c dx is equal to integral of cos is sine x is bx plus c. This is not x, so we should write the differentiation of this term in division form. So x derivative will be 1, so we'll be left with b. Now write the formula of by parts, that is integral f of x g of x dx is equals to f of x into integral g of x dx minus integral f dash of x into integral g of x dx whole dx. Substitute the values, so we'll get I1 is equal to f of x is e power ax into integral g of x is sine bx plus c by b minus integral f dash of x value is a into e power ax into integral g of x is sine bx plus c by b whole dx. So here the constant term is a by b. We will write it outside. First term will remain as it is. So this is equal to I1 is equals to e power ax into sine bx plus c by b minus a by b outside integral e power ax into sine bx plus c dx. So this function is completely nothing but our question which is given, which is equal to, we have taken this as I term, right? So we'll get I1 is equal to e power ax into sine bx plus c by b minus a by b into I. Substitute I1 in equation 1. So we'll get I is equal to minus 1 by b e power ax cos bx plus c plus a by b into the value of I, which is value of I1, which is e power ax into sine bx plus c by b minus a by b into I. I is equals to, here it is minus e power ax cos bx plus c by b plus a multiplied, so it is a into e power ax into sine bx plus c by b into b is b square minus a into a is a square by b into b is b square I. We'll transpose this term to that side, so it is I plus a square by b square into I is equal to minus e power ax cos bx plus c by b plus a e power ax into sine bx plus c by b square. Now taking LCM here and here both sides, so here it will be ib square plus a square I by b square is equals to, here there is b square is the LCM, so here we need one more b, so it is minus b e power ax into cos bx plus c plus a into e power ax sine bx plus c by b square. So both the sides b square gets cancelled out. Here taking I common, so it is a square plus b square is equals to, here we can take e power ax common, so we'll be left out with writing the positive term first, so it is a into sine bx plus c and the negative minus b into cos bx plus c. Bringing this term here to this side, so it is I is equal to e power ax by a square plus b square into a sine bx plus c minus b cos bx plus c is our answer.